All right, so in this video, we're going to look at multi-step factoring and solving by factoring. So remember with multi-step factoring, we have a few different types of factoring. We have GCF, we have trinomials, which are like our X game, and we also have difference of squares. So we're looking for things that have multiple, some of the multiple steps in them. So I've got two examples for us to look at. The first one, when you look at this, there is no GCF that comes out. So I will tell you, neither of these have GCF. Probably should have given you some better examples, but here we are. But this one looks like difference of squares to me. And the reason is because I know that I can break up x to the 8th as x to the 4th times x to the 4th. And I can break up 16 as -4 and +4. So when I break that up, I'm going to get x to the 4th minus 4 and x to the 4th plus 4. Remember, it doesn't matter what order we write those in. Now, what's tricky here that we didn't see previously is that these right here, this is actually another difference of squares question. Notice this is still a perfect square, and so is that, and it's subtraction. The problem with this one on the right side is that it is stuck, and it is stuck because of the addition. Because this is a +4, I can't go any further. But the one that is difference of squares, I can actually break that down again, and it's going to become this time x squared plus 2 and x squared minus 2. And then the one that does not break down, I'm just going to copy again, x to the 4th plus 4. And now I'm just going to check one more time that none of them are difference of squares. Obviously, the addition ones are stuck. And this one in the middle is subtraction, but the problem is that 2 is not a perfect square. So because all of them are to their stopping point, I have now completely factored out that question. All right, if I look at this one to the right, this looks like it should be trinomial, but it should kind of alert you. You should notice that this has a 4th power here and a squared in the middle, which is a little bit different. So for a minute, I'm going to pretend like that's not anything different, and I'm going to set up my x game. Two numbers that multiply to give me -36 and add to give me 5. And hopefully you are going to come up with 9 and -4. So the difference here, when I break my factors apart, normally I would break this x to the 4th apart as, if it was x squared, I would break it apart to be x and x. But this time, because it's a 4th, I'm going to break this apart to be x squared and x squared. Okay, so now I'm going to finish my factors like I just said. X squared plus 9 and x squared minus 4. So notice that that part is still the same. Because this is multi-step, we want to always check, are the things that I have here now finished, or is there anything else that I can do? So I'm going to look at this first one, x squared plus 9. That is stuck because of the addition, even though 9 is a perfect square. And my other one, x squared minus 4, that actually is another perfect square, so I can break it apart again. So it's going to become x plus 2 and x minus 2. And then my factor that was stuck is just going to come right down in the middle, x squared plus 9. So the last thing I want to show you on this multi-step is just a quick way to check that you've gotten everything correctly. So if you look here, I'm going to highlight some things. X squared times x to the 4th, that gives me this x to the 8th that I started with, right? 2x's, and then 4 is 8 altogether. If I do the same thing with the last numbers, 2 times -2 times +4 does give me 16 here at the end. You can check the same thing on this other question. X squared, wrong pen. X squared, x, and x is x to the 4th right here. And then same thing, 9 times 2 times -2 is -36. All right, let's look at solving by factoring. All right, so for this last part, we're going to talk about solving by factoring. And the first thing I need to tell you is about solutions on a graph. We haven't really looked at this part of graphs yet. But when we have a graph, we've talked a little bit about this, but when we have a graph, the solutions we are looking for are these points that the graph hits the x-axis. And we call these points zeros. They are also called roots or solutions or x-intercepts. But right now, I want us to focus on these two words, zeros and solutions, because they mean the same thing. So if we're going to solve a question by factoring, I'm going to give you some examples. Okay, so what I have for you here are 4 examples that have already been factored. I want you to pause the video and go ahead and copy these down with some space to add some things. All right, now that you've copied those down, I want to talk about how we solve them from this point and a few things to note about them. So the first thing that I actually want you to know, and this is important for how we solve them, is that all of these problems start out as equal 0. And so the first thing that you need to do is underneath these examples, if you'll put a star in your notes, you need to tell yourself that it must equal 0 first. Okay, so now that it's equal to 0, we have this thing called the zero product property. And I'm just going to slide my slides so I can write these things with you. And what the zero product property says is that if you have any set of things multiplied together and they equal 0, then one of these things must be 0. And you can think about that for a minute. Like the only way to have a multiplication problem that equals 0, 2 times 0, 0 times 8, the only way to get something to equal 0 is at least one of the numbers has to be 0, okay? So we're going to use that concept to answer these questions. So this first one in the top right, though I have two factors that are multiplied together to equal 0. So either this first one equals 0 or the other factor equals 0, or possibly both. If the first one equals 0, then x equals -2, right? Because I can subtract 2 from both sides. If the next one equals 0, then x is going to equal -3. So these quadratics, similar to absolute value, have 2 solutions. So I've got x -2 and x equals -3. All right? Same thing can happen on this one on the top right. I have 2 factors that are multiplied together to equal 0. So that means either 2x plus 5 equals 0 or 2x minus 5 equals 0. I can subtract 5, so 2x equals -5, and divide by 2, so either x equals -5 over 2, or I can add 5 and divide by 2, and x would equal 5 over 2. Again, notice that I have 2 answers. On this one on the bottom, so if you're making notes to yourself, sorry, I should have said this. This one on the top, if you want to make a note to yourself that this right here is x-game factoring or trinomial, even though I didn't work that out, you may want to have that just for yourself. The one on the top right, this was difference of squares. So notice that I split it apart. This one on the bottom left is GCF. So I noticed that I could take an x out of both of them, and then I set it up. So now I'm back to my same thing. I have 2 things multiplied together that equal 0. So either x equals 0 or x plus 2 equals 0. Now sometimes people get stuck, but there's nothing to do here. X just equals 0. On the other one, I can subtract 2 on both sides, so x equals -2. And again, I have 2 solutions. On this last one, since you're taking notes, this last one is GCF. So notice that I took an x out. That's what this x is out here on the outside. And then this one was trinomial. Okay, so now I have, if you notice, I've got 3 things that are multiplying together, but again, they equal 0, so I'm going to set up my options. Either x equals 0 or x minus 3 equals 0 or x minus 5 equals 0, which means x equals 0 or x equals 3 if I add 3 to both sides, or x equals 5 if I add 5 to both sides. All right, the last note that I want to make to you is that I want you to recognize a few things. All of these at the top had, or most of these had 2 solutions, and that is because this is x squared. So you might want to make a note to yourself, or you definitely should make a note to yourself, that x squared is going to give 2 solutions. So you can see that on all of these examples. The top right has x squared, and it had 2 solutions. I had x squared on the bottom left, and it gave me 2 solutions. The one that is different is this last one. Notice it has x to the third, and that gave me 1, 2, 3 solutions. So you can make a note to yourself that x to the third will give 3 solutions. And you could probably guess x to the fourth is going to give 4 solutions.